Welcome back to Quick Soil Mechanics Lessons with Brian. Now, lessons on pore pressure. In this video, we have the myth of hydrostatic pore pressure, part 2. I like to call this one piezometers, a tale of two tailings facilities. So, site number one was we were at the end of in situ testing, and at this time I was really a mining engineer. I wasn't yet a geotechnical engineer, so I didn't know a lot about just general soil mechanics. So we had a whole bunch of piezometers, isolated tip piezometers that could be drilled in or pushed in. And I had a whole bunch of pipe, and I called up my boss and I said, "What am I supposed to do with all these pipes and piezometers?" So here's a little diagram of our facility: tailing surface and a permeable base because there's an under drain. So I called up my boss and he told me what to do, and I thought he was just wasting the client's money because, like I said, I was not yet a geotechnical engineer and I didn't have a very good understanding of soil mechanics. So he'd been looking at the CPT data and all the data that came with that. He said, "Well, take all those piezometers and insert them into basically the same location, but at different depths." So I thought, okay, well, this is not very useful data for us. It's not going to help anything, and it's just going to make us look worse. Worse? Bad? Anyway, so I put these in, and I waited for these things to stabilize. And the first pedometer gave me a certain depth. The next one gave me a different depth to groundwater. The third one gave me a different depth. So I had some learning to do. So when I got back to the office, I really needed to find out why this was happening. And eventually I did, of course. So what was going on here is we have a downward flow due to the permeable base here. And if we look at head versus depth, we can see the shallowest one had a certain head on it, the next one. So this field pore pressure is different than hydrostatic. So in this case, we wouldn't know what hydrostatic was. If we just installed one of these things, we would have no idea what's going on. So installing more than one of these, or just doing CPT, pore pressure dissipation test, can give you a lot of information. And single piezometers just by themselves are really not all that helpful. So you can see here in this case, there's no such thing as hydrostatic because we have flow at the bottom. If you remember lesson 1, we were talking about the spring and dash pod or odometer, consolidometer. So there's double drainage at the top and the bottom here. So we don't have hydrostatic pore pressures. And if I had installed another one of these things close to the drain, I might have seen something quite different. So I might have seen this coming back towards zero pore pressure, just like that odometer or spring and dash pod. So zero pore pressure at the top, zero or very close to zero at the bottom, if we've got an ideal drain anyway. So we had a pore pressure distribution like this. It's nothing like hydrostatic. And so this is the importance of understanding the pore pressure regime. And it's seldom hydrostatic, and using hydrostatic in a slope stability analysis is not realistic. But if you have a lot of data points like this, it sure can be helpful in solving slope stability. So, if I only had one piezometer, I would have had no idea what's going on with the pore pressure regime. And in fact, I may be dangerously underestimating the pore pressures if I thought something was hydrostatic and I only had one point. The actual water table might be a lot shallower than I had assumed, especially if I just put in that last piezometer. I would think that there's practically no phreatic surface, no water table in there. So that could be very dangerous, right? So I had site number two. This is on the same trip, but a different site, a different state. And so it was a similar situation where we got through with our in situ testing. My boss was looking at all those results remotely. And I had all these pipes and all these isolated point piezometers that I could install. And so my boss again told me, okay, go out there and install them at different depths. And here this one's a little bit different because we've got an impermeable base as compared to the first one where we had a permeable base. So I called up my boss and he says, okay, you need to add some pipe joints to the top of those pipes. And I thought, well, this is not very helpful, but I did as he asked. And we went away and we came back the next day, and guess what? They were making water out of the top of those pipes. Well, how come? Well, it was artesian pressure, and it was because of the rapid rate of rise in the tailings low permeability, and the absence of drainage. So on these two different site investigations, we had completely the opposite cases. One was drained, this one is undrained, and actually has excess pore pressures in there because of those conditions, rapid rate of rise, the low tailings permeability, and the absence of drainage. So again, we don't have hydrostatic. We have something well in excess of hydrostatic. The first one we had something less than hydrostatic. So you can have a lot of different pore pressure regimes. So again, if I only had a single point, it wouldn't be very helpful. And so I really dislike having a single piezometer trying to tell me something. And you can probably see why with these two different site investigations. And remember back to the spring and dash pot, this would be where the load is applied and the water is trying to get out as fast as it can, but our clay layer's keeping it in there, right? So we're a long way from consolidating this thing under normal conditions. So anyway, that was the tale of two site investigations. Kind of a lot. We will uh, have more in the next lessons, and thanks for hanging in there with me.